So the numerator will be 4k minus 1. And then I square that, so 16k squared plus 4k plus 1. That's how you factor the numerator. Factor in the denominator. Is there a GCF in the denominator? There's no GCF. So now it's a trinomial. So we have our bottoms up method. So factors of 12, numbers that multiply to be 12, that add up to be negative 13. And then they're going to go with k. So I'll have k something and k something. So what are factors of positive 12 that add up to negative 13? Good. So negative 1, negative 12. Now I can't just say that's the solution because I still have to consider that there was a 4 in front. That's got to be divided out. So you divide this by 4 and you divide this by 4. So because you can just do 12 divided by 4 and get 3, then this is just k minus 3. Okay, and then with the k minus 1 over 4, that's our bottoms up, so the 4 goes in front of the k. So that's 4k minus 1. Okay, now once everything is factored, whatever the numerator and denominator have in common, you can cancel. So this will cancel with this. And my final answer is 16k squared plus 4k plus 1. If you could factor the numerator, you would, but there's no factors of 16 that add up to 4. So that is as far as you can go. Okay, and then number 2. So on this one, you want to divide out a GCF. So what divides out of 12 and 48? 12. And n squared and n? Yep, so then that leaves me with n minus 4. And what can you divide out of 18 and 288? And then they both have an n, so take the smallest exponent, which is squared. So now on the bottom, we have n squared. 288 divided by 18. Now, what appears to cancel? You know, one thing that's really important to remind you of is that I cannot cancel this n right here with this n squared, because this n squared is part of this difference. You can't split up sums and differences, okay? So the only thing that could possibly cancel is the n with something after if there was an n times 16n minus n squared. But you can't separate this n squared from the 16. So what else can I do here? Nothing's canceling at this point. The top, that's as far as we can go. What else can we do down here?
Plus or minus 4.
Yeah, I think I know what you're saying. So n plus 4. Sorry, it should be the 16's in front. So 4 plus n times 4 minus n. Difference of squares, right? Now look up in these notes right here where it says recall. What does it say x plus y divided by y plus y is? 1. And what's x minus y divided by y minus x? Negative 1. So here we have this situation, and we just know that that's negative 1. So final answer would be 12n, but this negative now is just in front, so negative 12n over 4 plus n. Okay, let's do number 3. Now this is a multiplication problem, but you do not want to multiply until you have the whole thing simplified. So we're going to factor each part of the fractions. Now notice there's no number in front of the x squared. So what are factors of negative 24 that add up to negative 10? Close. They would add up to, but one's got to be positive, one's got to be negative. So it's negative 12 and positive 2. And that's why the x's, you know, it helps to write those out every time because you can actually check what your guess is. So that's x minus 12 times x plus 2. And then down on this, we just divide out the GCF, x squared. Up top here, we have a GCF of 5x. So that would be x minus 4. And then down here, factors of positive 48 that add up to negative 16. So they have to multiply to be positive 48 and add to be a negative, so they're both going to be negative. And it should be 4 and 12. And now still, before we multiply, you can cancel vertically and diagonally. So this x minus 12 right here, we can cancel out that with this x minus 12. Vertically with our x plus 2, x minus 4. Now what we have left is 5x over x squared. And whenever you have the same base, you subtract your exponents, so it's 5x so it'll be x to the negative 1, but if something has a negative exponent, where does it go? In the bottom. So that'd be your final answer. So again, what's the hardest part today? I mean, all we're doing is slashing things after we factor. So factoring, right? You're just cutting things out after you factor. So factoring is still the skill that's going to take the most time. All right, number 5, let's do that one. And notice this is division. The only difference between a multiplication problem and a division problem, and it says right here, multiply by the reciprocal. So that means just flip it over. Flip the second fraction over. Okay. So let's start factoring this on the top left. Factors of 24 that add up to 11. Eight and 3, right? So 8 times 3 is 24, 8 plus 3 is 11. So those go here and here. But what you have to notice here is that there's a 6 in front, so that needs to be divided out. So now you have s plus What divides out of 8 and 6? And then this is 1/2. This is why we call it bottoms up now, right? After you simplify the fractions, that goes up. So 3s plus 4 times 2s plus 1. What's up, Coach?
I just see how it's done.
Oh, yeah. Coach Q is like the best math teacher in the building. You guys just don't know it. It's top secret. You guys believe that?